Oh, okay. Alright, that makes sense.
Okay, so let's take a look. We know that from our red to red, we're going to end up getting approximately our 12.6 volts AC. Everyone understands that, right? That all makes sense. That's going from our red to red. Okay, so now if we're using our center tap, what's going to happen is that we got pretty much a series circuit here. We have two coils that are in series with one another. And those two voltages across those coils are going to have to add up to our 12.6 volts. So this coil is going to drop 6.3 volts AC. And this coil is going to drop 6.3 volts AC. Okay? So if I measure across both of them, then I'm going to measure my 12.6 volts. If I just measure across one of them, I'm going to measure my 6.3 volts. Either one I measure across, referencing the ground, I'm going to get my 6.3 volts. But to analyze what kind of signal I'm actually going to get, I'm going to look at, so here I got it hooked up to my function generator, or my AC outlet, doesn't really matter. And I'm going to look at my first alteration, that's where it's going to go positive. Okay, I'm going to go positive. So the polarity across my primary is also going to be negative, positive, and then back into my function generator. And then as long as we have our inversion dots correct, then I should get the same polarity going across our secondaries. So my first polarity is going to be negative, and then I'm going to split it up right at where my reference point is, because I'm going to divide up those two coils. I'm going to just treat it as two just separate components. So it's going to go negative, positive, and then negative, positive, and then so let's just say we let's just put a resistor across here so we can see it. So then what I have would be that the polarity across my resistor would drop the total voltage of 12.6 volts AC, and it would be the polarity would be positive to negative for the first alteration. Okay, so does that everyone kind of make all sense of that and how we're getting all those voltage drops? Okay, then our next alteration then, it's going to go negative positive. So this one's going to be, now the polarity across my source is going to switch directions. So now it's negative positive, so now my voltage across my coil is negative positive. And again, as long as my inversion dots are correct, my polarity across my secondaries then are going to go negative, positive, negative, positive. And then, as I go around, then my polarity across my resistor is going to change. And so now, what's happening is that on that first alteration, it went up, then it went down. That's what my voltage looks like going across that one resistor. So now, so, we're just, all we are doing is we're just switching it back and forth at the same frequency, but we're just having a voltage drop. So now what we're looking at is that now we want to measure referencing to our ground this time. Here I'm not referencing ground, I'm just measuring it to my other two outside leads of my secondaries. Now what I'm going to do is I'm going to measure and using my center tap and reference that voltage going across there. So I'm going to get rid of this here so you can kind of see how that voltage goes across that. So what I'm doing is I'm hooking up my oscilloscope. So I'll just, here's my oscilloscope here. And what I'm going to do is I'm going to just hook up my channel 1 here, and then I'm going to come down and I'm going to hook up my ground clip up here. So channel 1 then, on that first alteration, when this thing goes positive, so here's my first alteration, here's my second alteration. So when I'm looking at my first alteration, this thing is going to be positive, and my reference point is going to be more negative. So on channel 1, my output is going to go a little more positive. Then if I hook up channel 2, get my reference point on there. But channel 2 then, looking at my first alteration, is this one's going to be more negative. So channel 2 then is going to display going more negative, referencing to ground. Because I'm more get rid of this here. See it. So we can see that my reference point is more positive than what my actual output is, where my channel 2 is referencing. So channel 2 is going to be more negative. It's going to be inverted. And so that one's going to go negative. Then, when I go to my second alteration, then the polarity across here is going to change. So then I'll put that back up. And so now this is going to be negative, positive, negative, positive. Now when I look at channel 1, referencing it to this, I can see that I'm going to be more negative than what my reference point is. So now this one here on the second alteration is going to go down. Channel 2 now is more positive than what my reference point is, and so that one's going to go more positive. Since I'm measuring only across 1/2 of my coil, my peak amplitude is going to be only at 6.3 volts AC. And this one's going to be at 6.3 volts AC. The only difference is now, but they're going to be 180 degrees out of phase one another. But the potential difference, if I take my math function, if I did my math function on it, and took channel 1 minus channel 2, I would end up getting my big sine wave at 12.6 volts AC. I would get the difference between these two signals. They're just going to be 180 degrees out of phase one another. But the voltage potential between here, the positive 6.3 volts and a negative 6.3 volts, the potential difference between those two will give me my 12.6 volts AC. Everyone follow along with that? Yeah? All right. So this is what we're going to be doing when we get into solid state and using our diodes and stuff and building our power supply. We're going to be analyzing our circuits and analyzing it. You know, here's our polarities going across here, so we can find out what the polarity across our diodes are. All right. So get that up on your. So see if you can see that on your oscilloscope. So I want to see your channel 1. So this is using the oscilloscope. Otherwise, if I was using the MIDAC, so let's just use our MIDAC since that's what we got hooked up. What would have to go on this one here for my MIDAC? What channel? What would I want to hook up to?
AO negative 0.
Not negative 0.
Plus 0.
Oh,
Plus 0.
yeah.
And it's not going to be AO, it's going to be AI. It's going to be an input, right? We're going into an input, and that one's going to be our AI plus 0. Then what's going to go here then on my reference point?
Ground.
Yeah, A ground. You can go there, but not necessarily have to. It's because all we're doing is a measurement. So we've already identified that this is my reference point.
AI plus 1.
So this one, we always need to have 2 channels, right? So what would this signal here would be what?
The plus 1.
Our AI minus 0. We're going to take the difference between, that would be like our ground clip. Okay, so this is here's our probe, and then this AI minus 0, that's our reference point on our oscilloscope. We're taking the difference between those two. That's what we're doing even with a real oscilloscope. What it's doing is it's just taking the difference between this ground clip and this probe. It's just taking the difference and measuring it and bringing it up. That's the same thing with the MIDAC. It's just taking our plus 0 and our minus 0, looking at what the potential difference is between those two, and displaying it on the screen. Okay? So when we're hooking up the oscilloscope and we're using the ground clip, think about it as being a negative 0 on your MIDAC. When you're hooking up your probe, that's going to be your plus 0. Okay, that's going to be your non-inverting channel. So the same thing here then for your second channel then, this one's going to be your AI negative 0, and your channel 2 then is going to be your AI plus 1. That's all the MIDAC is doing, is it's just taking the difference between the inverting and the non-inverting channels. So if I had just my probe on my oscilloscope, here's this probe, and then I have my ground clip, just treat this as your plus 0 and your negative 0. Here's my here's my non-inverting pin, and then here's my reference point, my minus 0, my analog output. So this is my analog input plus 0 and my analog input negative 0. So when we're hooking it up the way of the MIDAC, this is the way it is, looks like according to the probe on the oscilloscope. Does that make sense? Yep, so we should always know how to hook up our oscilloscopes from either whether if it's on an oscilloscope or a MIDAC. So we're just looking at 2 points and we're just taking the potential difference between those 2 points and then the MIDAC is displaying it. Same thing with the oscilloscope. It's just taking our ground clip and our probe and it's taking a look at the difference between those 2 signals and displaying it on the oscilloscope. So it doesn't really matter. So just remember your minus 0 or your minus 1, that's your ground clip. Your plus 0 or your plus 1, that's your probe that would be on your oscilloscope. Just relate those two as being the same. All right, so get your 2 signals on your oscilloscope, and then I'll come around and take a look at that and see if you got your signals hooked up. All right, so what do you got for what's your voltage in going in?
5 volts.
5 volts peak to peak, and so.
Divide that by 0.15, I got 750 millivolts divided by 3.
All right.
Yeah.
5 volts peak to peak going, that would be going across, and that's going into your primary. Yep, so then you divide that. Yep, I got you.
Multiplied by your gain. They have to
There you go. All right, good. And then you can see that they're 180 degrees out of phase there. All right, let me, I'll get your. So I'm going to just go over one more thing, but then I'll get your lab checked out. So after you get it all hooked up, let me know and I'll get your lab signed off there. All right. Get yours going, Tyler? All right. Yeah.
Came out.
Oh, just strip it off and try to put it in there. Yeah, see if you can just sneak it in there for now.
Yeah.
Well, you have that op amp sheet on how to wire up your op amp. We'll have to take a look at it after we're done here.
Why are you pulling it down?
Apparently not.
He goes, if you figured you would succeed, then you know, I'm down to treat you like you're down.
Like, whoa, cowboy. Back up a few horses.
Okay, anyone else get their signals on their oscilloscope? Got it? Ready?
We got it. Here we go.
Is it the voltage that you're expecting then?
Yeah, two added together.
Yeah, sometimes it gets kind of asshole. Kind of gets kind of crazy. So you got you're set at 10 volts peak to peak going into your primary, right? Yep. So approximately, what would you get on your secondaries then? Going across the forehead. 1 volt peak to peak, and then going halfway across from each one you get by 0.15. That's a good thing.
You can do the other two, but I don't know if they'll work.
Yep, and then you can see that it's 180 degrees out. All right, so remember this. We're going to go. We're going to do this again in solid state. All right, good. Now yours all is one there, Buckeye. And what did you get for a bolt score across yours? What do you got? So you got one bolt piece of piece, so yours is just definitely trying to less than that. What's that? Yep, that's the way it should be. 180 degrees out of space.
61, dude.
Yep.
Doesn't matter.
All right. Get your Jake.
No. On right now.
I was just kidding.
Let's see if I get that. I find that op-amp printout is.
Control your.
You do? Yeah. Oh,
What'd you say?
Have you seen that? He's like, no, it's a deal where he's doing the voice combos, you can hear him on the iPod, he's like,